right? Okay, so this is the course content, and don't worry that if you are not familiar with these technical terms, or if you are not familiar with these topics, don't worry, right? So I mean, this is a course for beginners, right? So you might be from any field, you might be from IT field, engineering field, or even you are like not done a degree, or you are like currently working, right? So it's fine. This is a beginner course where we can cover these things very easily from 0 to Z, right? Or 0 to, right? You can go from very basic levels to advanced levels, so no need to have a prior knowledge, right? Anyway, I will go through the course content and give you an idea what we are going to cover. But if you are not having what are these things, the idea behind these things, don't worry, since we are going to cover these things from very basics, no need to have a prior knowledge, as I mentioned earlier, right? So today will be the week 1, right? So in today, basically what we are going to do, we are going to cover the introduction part, and we are going to discuss what's machine learning, what's deep learning, what are neural networks, and how these things are working, right? So what are those kind of things will be discussed today in the lecture, right? And so now we are at the introduction to course part, and then we will move on to the deep learning and neural networks introduction later. And the practical session on Tuesday, coming Tuesday, will be nothing related to neural networks, right? So we are not going to cover anything related to neural networks on the practical sessions coming on Tuesday, right? What we are going to do, we are going to set up our environment, our coding environment. We are going to install our coding environment, the integrated development environment, right? And also we are going to cover the basics of Python, the essential Python programming concepts, right? Now, throughout the course, we are going to use Python for neural network implementation, right? So therefore, we need to have a proper Python programming knowledge with us. So that's why the first week's practical session is dedicated to Python programming, right? What we are going to do, we will cover everything from very basics, but I'm expecting from you to have a kind of a basic programming knowledge. Like it can be like C programming, C++, Java, Python, or anything, but I want to have like a basic programming background. No need to have that much of a knowledge, but a programming background. I mean, you have to have like a basic programming. I mean, let's say like this. I want you to know what's a variable, what is like a array, right? What's a loop, what is decision making, what's if else. That kind of simple thing I'm expecting from you. Other than that, no need to have a prior Python programming knowledge, right? You may have done C, C++, Java, or anything, but it's fine. Okay, so is there any issue with the audio? Okay, right. I think, yeah, I think that's the internet issue with Pramod. I think there's it's a internet connection issue. Anyway, it's fine. I mean, I'm going to upload this and you can view it later, right? Okay, that kind of technical issues are there when we are doing these live lectures, but there are a few positive points, right? So we are going to like stay at home leisurely, and we are going to spend these 3 hours. So what will happen, we are going to go to the institute and do these things. So we are going to like right, so we are going to take few hours to go and come back, right? So we need to have the right, so we are going to spend our whole day, but this is quite fine. We can stay at home and we can do everything and quite comfortably, right? So there are few advantages over the physical conduct of lectures when we are doing live lectures, but some technical issues might be arrived, right? Might be arrived. Other than might be arise, but other than it's quite okay. So as I mentioned, the practical session on the first week, we are going to totally cover the Python programming basic. But if you are a good programmer, I mean, don't worry. I mean, we are going to go to the advanced stuff later, but it's a good chance for you all to like be familiarized with Python programming environment, since we need that foundation throughout our course, right? And also the assignment of the first week again will be uh, from the basic Python programming, right? And on the second week, we are going to start, actually, we are going to start the neural networks, the theory of neural networks, the feed-forward type neural networks. But we are not going to finish everything on that day. So the second day, again, the practical session will be basically about the modules, the Python modules that we are going to use in this course, like NumPy, Matplotlib, some external modules that we are going to use for this course. So essential Python modules will be the second lab, and the assignment similarly will be based on something from that. Then the feed forward neural second part will be covered on the third week, and the first practical related to neural network will be on third week, right? So in the first 2 weeks, I'm creating the foundation for the course, right, to make you comfortable with the practicals and the stuff that we are going to, right? So with deep neural networks and the Python programming environment, right? So that's the first 2 weeks are dedicated for that. And eventually we are going to move on to that advanced stuffs, right? So neural networks, the basic of neural networks, neural network architecture, the forward propagation, and on third week, the optimizers, loss function, back propagation algorithm, and overfitting, underfitting. And so the practical sessions, you can see these are like, they are also advancing, and they are like eventually getting harder and harder, right? Right. So then we have mainly 5 stages: the introduction stage, and the supervised deep learning stage, unsupervised deep learning, reinforcement, and finally in the final right, in the final stage, what we are basically doing is to we are trying to, like, now in these 4 stages, what we are mainly what we are targeting to do uh, is to train neural networks, build neural network models, and train it for our own data, and implement several applications. So finally, what we are going to do, we are going to then learn how to deploy these neural network models in web applications, or web applications, and yes, other than that, mobile applications and cloud servers, right? So basically, I mean, so to train neural networks, how to use them in practical applications, right? So we are not going to train neural networks and use it in our computer, but we have to like upload it to servers and do some advanced stuff. So that deployment part will be covered at the end of the, I mean, the final stage, right? I'm not going to go through these contents in some times. I mean, you may have the basic knowledge, but sometimes everyone will not be familiar with the core, I mean, the technical stuff. So don't worry, right? After the course, I mean, after the 12 weeks, you will be familiar with everything, every technical word, every technical thing. I mean, all the topics here, since I'm going to cover from the neural networks from very basics, right? Okay. Yes, Camila, some parts, I'm not exactly, but yeah, I'm planning to do those kind of things. Yes, okay. All pretty much everything, yes. So tools. So what we are going to do in this course, other than the theoretical stuffs, what are the tools that we are going to use for this course, right? So we will mainly go with Python, right? For the 90% of the implementations in this course, we will use Python programming language, and some contributed modules, some software platforms will be used, like TensorFlow, Keras mainly for the neural network implementation. TensorFlow and Keras will be used. So TensorFlow and Keras are, I mean, TensorFlow is a deep learning neural network module provided by Google, or open source neural network implementing software platform provided by Google. And Keras is kind of a API I will explain these things when we are going to go to the practicals. And OpenCV, so these TensorFlow and Keras will be used to implement neural networks in Python in our practical implementations. And OpenCV will be used for our image processing based applications, image pre-processing and image, yeah. So image based applications, we are going to use OpenCV. And scikit-learn library, we will use sometimes, uh, not like these libraries, but sometimes we will use scikit-learn library for some tasks in our implementations, right? And these libraries are like contributed libraries, right? For our implementations, we will use this NumPy, Matplotlib, and Pandas libraries for like contributed or assisting libraries, right? Third-party libraries. But mainly we will focus on TensorFlow, TensorFlow and Keras, and also OpenCV. So these will be the main libraries, and these are like helping libraries, right? And we will use again the Python programming language will be used, and the development environment, as the development environment for this course, we will use the Anaconda Navigator, sorry, Jupyter Notebook in Anaconda Navigator, right? But if you are currently familiar with some other integrated, development environment like PyCharm, right? Or any other development environment, it's fine, right? It's fine to use that. If you are familiar with any other development environment, it's fine, you can use that, but I'm recommending you to use Anaconda Navigate, sorry, the Jupyter Notebook. Yes, you can do it with Visual Studio Code as well, but the issue is when we are dealing with neural network training, I'm not sure, like it's getting slower when we are going to use Visual Studio Code, like that kind of development environment. But it's recommend to use Anaconda Navigator, Jupyter Notebook. But if you are familiar, and you can use that, right? But I recommend, yeah, you can use Google Colab as well, right? But sometimes some large data sets, sometimes we might have to use some large data sets. In that case, what will happen? It's quite hard to upload that to the server, and it's sometimes getting disconnected, right? Like periodically, right? But for small implementations, we can use Google Colab, right? And we can upload the data sets as well. I mean, we can upload the data set to Colab as well. Yeah, it's also fine, but sometimes when we are dealing with large data sets, it might be an issue. Other than that, Google Colab is fine, but mainly my recommendation is for Jupyter Notebook. You can use the Jupyter Notebook and implement the coding sections, right? Okay. Right. So I will, I will show you how to, I will show you how to download the Jupyter Notebook quickly. Yes. So it's quite simple. I mean, it's a small few steps to be followed, right? So you can search for Anaconda download, right? So if you are not familiar with Anaconda, this is not another programming language. This is just a development environment, right? So Anaconda download, and go to this individual edition, right? Individual edition. And yeah, so then you can directly go to the download, right? And here, I mean, it's supported for every platform, right? If you are using Mac OS, Linux, or Windows, you can download any version, right? So according to your OS, right? So 64 graphical installer, but make sure that you are going to download the Python 3.7 version, right? Python 3.7 graphical installer. And what we have to do, download this and install, and it will be like a small, it will be like a general, I mean, installation process, right? No need to do anything. just install it like a normal application, normal software, right? So you have to download the .exe file will be downloaded from here, and you have to install it. Make sure that you are going to install it before the Tuesday's session, right? Make sure that you are going to download it and install before the Tuesday session, since we are going to use it for our programming part on Tuesday, right? So download it here according to your OS and install it like a normal. It's a normal installation process there, right? Okay. And if you have any questions, as I mentioned earlier, so please contact me, or we have the WhatsApp group, right? So in the WhatsApp group, we can discuss. No, we no need to install Python before installing Anaconda, since Python is inside the Anaconda navigator, so it's already there. So we no need to install the Python separately, right? So you can use Python, you can install Python separately, but here no need to do that. Later, if you need for some kind of application, we might need that. In that case, we will install it separately. For now, no need to install Python separately. We can use the same thing, just Anaconda. We can code in Python, right? Okay, so that's pretty much everything. And yeah. Okay, so I'm going to use these two books as the references for this course, and the first one will be the deep learning book by Ian Goodfellow. And yeah, yes, I have already installed all the version of Python. Would it be a problem? Anaconda. Dilum, do you have the Anaconda installed in your computer? No, it's fine. Then you can download the latest version of Anaconda and install. So it's not going to be like a issue with uh, the already existing Python and Anaconda. No need to worry about that. It's not going to be a problem. Install Anaconda separately, so it will be fine. Okay, right. So these will be the two reference books that I'm going to use, right? So the online version of this book is available, right? And this is also available. I will yeah, so you can find it in the internet, right? These two books will be the references for this course. Okay, right. So that will be the course overview, right? Everything, how the course will be conducted, and everything is there, right? So now, if you have any questions regarding the course introduction, the course overview, please ask if you have any questions regarding these things, anything to be clarified. Yes? Anyone? Any issue? Yes, please. Yes, we have a question here. Yes. Okay. So there's a issue, right? So this issue was raised earlier as well. Okay. Now, please is there anyone who cannot understand Sinhala? Is there anyone who cannot understand? I mean, not understanding is like I mean, you have to understand the content in Sinhala, right? So I mean, you have to have a good Sinhala knowledge, right? Anyone who cannot understand Sinhala, please? Yeah. Yeah. Okay. Yes. Others? Anyone, please? if you cannot understand Sinhala, the content, these I mean, right? පොඩි පොඩි දේවල් නේද මේ මම කතා කරනවා වගේ පොඩි දේවල් නම් තේරුම් ගන්න පුළුවන් දැන් ෆිල්ම් එකක් බලනවා වගේ තේරුම් ගන්න මම අහන්නේ මේ කෝස් කන්ටෙන්ට්ස් උත් එක්ක සිංහලෙන් තේරුම් ගන්න බැරි කවුරු හරි ඉන්නවනේ. Okay, so we have, okay. Yes, right. Okay, so we have like we have several people right here cannot understand Sinhala very well. Okay, so there is there was a request to conduct the things in Sinhala as well, right? So there was a request. So what I will do, right? I'm not going to conduct it in Sinhala since everyone is not going to understand it then, right? So what I can do is I can like conduct it in both Sinhala and English, right? That means I'm going to explain it, right? Explain it in English, right? And also in Sinhala. I mean, not like election campaigns, right? So first Sinhala, then English. No, not like that. But the deep stuff and some important points, I will explain it in Sinhala as well, right? So I think that's the only thing that I can do, since I can't completely go with Sinhala. Then some of you might not be understanding it well, right? So what I can do is like I'm going to like continue with English, right? Mainly in English, and the deep stuffs and the hard stuffs, right? I'm going to explain it in Sinhala, right? So that's not going to, I mean, don't think that okay, so it's going to take time. No, not like that. I'm just like repeating the same stuff in Sinhala, right? Ekama poddaka apo Sinhala වලින් කියනවා. Okay, right? Okay, so I think that will help, right? Okay, yes. Okay, so any other issues? And also like please try to be interactive. I mean, here, and also we have the WhatsApp group, and you have my phone number. You can get my phone number as well. So like I like to answer your questions, and I like to always be helpful, right? To clarify your issues, to rectify your like errors you are getting in the when you are going to code, right? So it's really interesting on Tuesday's session, since we are going to do the coding stuffs, right? So then when you are going to later view it, right? So please, if you have any errors, now you are going to get errors from Tuesday, right? Tuesday නම් ගොඩාක් errors එනවා අපි codes ගහද්දි. ඉතින් ඒ errors, so if you have like, you can contact me and clarify those issues, right? So please feel free to contact me, interrupt me, call me, message me, right? And clarify those issues, right? So this is not like, right? So no need to wait until the next week to clarify those issues. Please call me, drop the message on the WhatsApp group, since we are all here to learn, right? So we want to get the maximum out of it, right? So please feel free to be like that, right? Okay, so if you have no issues other than that about the course, right? So I will move on to the introduction part for today, right? Okay, so what I'm going to do here, right? So as I mentioned, I will be discussing about neural networks today, right? I will be discussing about neural networks today, but I'm not going to go to deep and teach you or discuss how to train a neural network, how neural networks are training. No, not like that. But I want you to familiarize these ideas of machine learning, artificial intelligence, deep learning, and these algorithms and those kind of things, right? So like it's kind of ice-breaking session where we can discuss everything about AI, machine learning, deep learning, applications of AI, machine learning and deep learning, those kind of things, right? Okay. So mainly, I think you may have seen this earlier as well. So we have mainly like 3 categories mainly, right? So inside these things, some other things are available as well. But mainly this categorization is there: AI, machine learning, deep learning, right? So I think you are familiar that, I mean, we are going to, in this course, deep learning and neural networks, we are going to discuss about something related to artificial intelligence, AI ගැන මොකක් හරි දෙයක් තමයි මේ course එකේ ගැන කරන්න යන්න කියලා දැනගෙන ඉන්නවා ඔයා කොහොමත් ඒක දන්නවා right so this is something related to AI ඇතුලේ we have two main things I mean machine learning is a subset of artificial intelligence right machine learning is subset of artificial intelligence and inside the artificial intelligence we have machine learning as I mentioned earlier and inside machine learning we have another category called deep learning machine learning ඇතුලේ තව තියෙන category එකක් තමයි deep learning කියලා කියන්නේ right okay so what is this artificial intelligence when did you first heard of this ඉස්සලාම AI artificial intelligence right so කවද්ද මේක ගැන ඔයාලා ඉස්සලාම ඇහුවේ AI කියන එක ගැන මොකද්ද මේ AI කියන්නේ right artificial intelligence I mean so this is a yeah so we have an answer interesting okay Night Rider yeah great yes Night Rider we saw some art I mean that's beyond artificial intelligence right so that's something yeah so that's something Night Rider is something I mean beyond artificial intelligence anyway yeah Eagle Eye yes and can you remember there was like a film called AI as well right AI का film right okay anyway artificial intelligence the name suggests right intelligence so what do you mean by intelligence right බුද්ධිය කියලා අපි කියනවා intelligence right so we say right we say that we have the best intelligence out of all the living beings අපි කියනවා human වලට තමයි හොඳම intelligence එක තියෙන්නේ අපි කියන්නේ right කොහොමද කියන යන්නේ අපිම කියනවා human වල තමයි බුද්ධිමත්ම right හරියට නිකන් අර මොකද්ද right it's like the Miss Universe is always from Earth right Miss Universe is always from Earth other I mean other planets are not competing right so likewise human we say that we are the most intelligent living being right in the world so I mean there's a reason right so we have like using our intelligence we are going to do a lot of things right that means we can read right so we can read අපිට කියවන්න පුළුවන් අපිට මේ වචන කියවලා තේරුම් ගන්න පුළුවන් right so we can I mean we can listen and understand අපිට කවුරු හරි කියන එකක් අඳුර ගන්න පුළුවන් so we can detect objects or we can identify objects right අපිට objects අඳුර ගන්න පුළුවන් අපිට වාහන අඳුර ගන්න පුළුවන් පාට අඳුර ගන්න පුළුවන් මිනිස්සු අඳුර ගන්න පුළුවන් right so like humans we can like so we have these things I mean we can like we can identify people from their face and their shape right so their height අපිට කවුරු හරි නිකන් ඈතකින් දැකලා පැත්තෙන් දැකලා උනත් කියන්න පුළුවන් මේ කවුද ඉන්නේ කියලා right we can I mean we can identify everything we can identify I mean thousands of objects thousands of different objects right and we can do mathematical operations we can do calculations right we can drive cars right we can translate something from one language to another language මම මේ දැන් කියපු සිංහලෙන් කියප එක මට ඉංග්‍රීසි වලට translate කරන්න පුළුවන් right so that's what we are going to do with our intelligence we can I mean do a lot of things using our intelligence right okay so that's what you call the intelligence so artificial intelligence what we are trying to do the human intelligence so whatever the things that we are going to do with our brain not brain our intelligence what we are going to do with our intelligence we are going to replicate them or we are going to implement them in artificial environments that means machines right so it can be a computer it can be a mobile phone it can be any electronic device if you are trying to like if you are trying to implement something that a human can do using human intelligence if you are trying to replicate or if you are trying to implement that thing in a machine right or any electronic device මොකක් හරි electronic device එකක අපි ඒක කරන්න try කරනවා නම් අපි අර කතා කරපු එකම right අන්න අපි ඒකට කියනවා right අපි ඒකට කියනවා artificial intelligence so that's called artificial intelligence right Okay, so that's the concept artificial intelligence. Whatever the things that we are going to do with human intelligence system, if you want like if you want to replicate or if you want to implement them in machines, so that's called artificial intelligence. The concept artificial intelligence, that's kind of a concept artificial intelligence, right? Understood. So that's what artificial intelligence. So now we have a lot of applications of artificial intelligence, right? So I will in the next slide I will explain those things, right? So machine learning is a subset of artificial intelligence. I mean, artificial intelligence is full of concepts, as I mentioned, and machine learning is where you are going to find the practical part of the artificial intelligence, machine learning, the practical implementation of artificial intelligence. So artificial intelligence වල කියන දේවල් ඇත්තටම implement කරන part එක තමයි අපිට ඇත්තටම implement කරන්න පුළුවන් part එක. මේ වෙද්දී ඇත්තටම implement කරලා තියෙන part එක තමයි machine learning කියන්නේ. Right? Machine learning. So in machine learning, we are going to find computer algorithms, or algorithms, not computer, but algorithms, right? Inside the machine learning category, we are going to find algorithms. So those are called computer algorithms. So the specialty about these algorithms, you may heard the term algorithms, right? The specialty about these algorithms are that these algorithms can be trained for a specific application, right? These algorithms can be trained for specific applications. Like what? So we can train a computer algorithm to perform self-driving, right? Or we can train a computer algorithm to predict stock or predict stock market values, right? We can train a computer algorithm to translate from one language to another language. So that's called machine translation, right? We can train a computer algorithm to predict whether a patient is having COVID-19 or COVID-19 not, I mean COVID-19 positive or COVID-19 negative, right? Understood. We can get the algorithm and we can train it to perform another task, right? I will give you one example. We can train a computer algorithm to compose music, right? So music generation. That means now, without having a proper knowledge about, I mean, proper skill on music, using artificial intelligence, now we can create, or now we can create, yeah, we can create music tracks, right? So I mean, they are very beautiful and they are very like pleasant music tracks we can generate from artificial intelligence. I will show you some examples, right? So we can do a lot of things. Now here, the important, I think you might found the important point. Now I discussed several things here: self-driving, stock market value prediction, language translation, object detection, healthcare. I mean the COVID-19 positive negative healthcare, right? So that means AI, machine learning, can be used in any field, right? දැන් මේ කතා කරපු applications එක field එකක නෙමෙයි. Medical industry, right? The healthcare sector, and finance, stock market prediction, and self-driving car, automobile industry, right? Several fields, several industries. That means AI, machine learning, this is not like a concept. I mean, AI is kind of, yeah, it's a concept and it's containing algorithms, but machine learning, AI, deep learning, these are like tools, right? And the most important thing is that we can use these things in, I mean, we can use these things in several industries, I mean, for several applications, the applications that we never thought of, right? Music composing, right? Using AI, right? Applications we never thought of, right? So that's the power of AI. Then that's the recent development or recent advancement of machine learning and deep learning. We have several applications, and I will show you example later that we can use artificial intelligence, machine learning, deep learning to play games, and they are performing well, and they are like defeating human experts of that game. I will show you some examples, right? So that's the power of AI and machine learning. So basically, as I mentioned, machine learning is the practical aspect of artificial intelligence, and we have computer algorithms which can be trained for specific tasks like self-driving, like stock market value prediction, like natural language transformation, like object detection. So several applications we can train it for specific application, and we can use it for future predictions. So that's the most important. We can train it and we can use it for future predictions. It's like that. What I mean, we can train a self-driving car, right? And we can then run it in the road, right? අපිට ඊට පස්සේ future predictions ඊට පස්සේ අපිට මේක පාරේ යවන්න පුළුවන්. එයා predictions දිදී යනවා. ඒ කියන්නේ පාරේ steering angle එක predict කර කර එයා යනවා. And also like stock market value prediction. So what we can do, we can train an algorithm for stock market value prediction, and later what we can do, we can use it for other. So what we can do then, we can predict the stock value of next day. Heta value එක predict කරනවා. So based on that, what we can do, we can decide whether to buy stocks or whether to sell stocks or whether to hold stocks, right? So that's what you call future predictions, right? And the deep learning is again another subset inside machine learning. Machine learning ඇතුලේ තියෙන subset එකකට තමයි අපි deep learning කියලා කියන්නේ, right? A subset inside machine learning, right? So this deep learning is now quite similar, right? Machine learning and deep learning are quite similar, but deep learning is a advanced, a high level version of machine learning, right? We have machine learning and deep learning, and quite similar. The concept is quite similar, but deep learning is a bit, not a bit, but advanced and a high level version of machine learning, right? So I discussed about computer algorithms, that we have some computer algorithms which can be trained for a specific task, as I mentioned earlier. Deep learning also the same. Deep learning is the same. Deep learning also has computer algorithms which can be trained for specific applications, and we can use it for future predictions as well. But the difference between the machine learning and deep learning, the algorithms in deep learning are high level versions. I mean, high level algorithms, complicated algorithms, right? Than algorithms that we are going to find in machine learning. Machine learning වල තියෙන algorithms වල ගොඩක් advanced high level algorithms තමයි deep learning වල තියෙන. එකයි මම කිව්වේ deep learning කියන්නේ high level version එකක් සහ advanced version එකක් machine learning වල, right? So in deep learning concept or the deep learning field, the algorithms that we are going to use are called neural networks, right? Deep learning වල අපි use කරන algorithms වලට අපි කියන්නේ neural networks කියලා. එහෙනම් මේ neural networks වී deep learning කියන දෙක connect වෙන්නේ deep learning කියන subset එකේ, machine learning වල තියෙන deep learning කියන subset එකේ use කරන algorithms ජාතියට තමයි අපි කියන්නේ neural networks කියලා, right? So what are the algorithms that you are going to use in machine learning? So they are like not that much powerful, right? It's a powerful algorithms in machine learning. They are like yeah, they are good, but those algorithms are low level algorithms, right? So like linear regression, if you may have heard. Yes, okay. Now we have a question here, right? Okay. Without having a knowledge on machine learning, can we go to deep learning? Yes, exactly, we can go. Since yeah, we need the basics of machine learning, I'm going to cover it, right? The basics of machine learning will be covered in this course, but we can directly go to the deep learning, since with that basic concepts of machine learning, we can directly move on to the deep learning. The thing is, right, I used to do this, I'm still doing, right? I used to do the machine learning and image processing course, and a new course will be again started. But the thing is, that's like as per the I mean, the recent past, right? I mean, let's take the previous 3-4 years, right? Or 5 years, let's say 2015 to 2020, right? It's quite hardly we can found machine learning I mean algorithms that use machine learning for their I mean applications, right? මේ අවුරුදු 5 අපි ගත්තොත් එහෙම machine learning use කරලා දැන් කරන applications ගොඩක් අඩුයි. උදාහරණයක් විදිහට for example we can never train a self driving car using a machine learning algorithm. අපිට කවදාවත් machine learning algorithm එකකින් self driving car එකක් හදන්න බෑ. කවදාවත් බෑ. We can't do that. The issue, I mean, the reason behind that, the deep learning algorithms, right? I mean, machine learning algorithms cannot solve or cannot be used for that kind of complex applications. Now, self-driving car is a complex application, right? It's a quite sensitive and a complex application. For that kind of complex applications, we can't use machine learning algorithms. So we have to use deep learning. So now the trend is deep learning. You can use it, you can search it in the internet, right? You are not going to find anything, any recent application implemented using machine learning, but it's like this. Now you are going to drive a auto transmission vehicle, right? Auto transmission vehicle, right? But it's recommend to go through, I mean, it's recommend to drive a manual transmission vehicle first and come to the auto transmission vehicle, right? So that's how we are going to like obtain the license as well, right? So, right, it's like that. So now machine learning is the old one, right? Deep learning is the newest one, right? The latest one, right? And everyone is using deep learning neural networks these days, right? But it's worth to go through machine learning and cover the basic stuffs and come to deep learning, right? So I will do that. I will give you the introduction to machine learning as well, right? So don't worry about that. But I'm not going to go through all the algorithms, all the concepts in machine learning, since it's not required to go to deep learning, right? So we can move to deep learning, but we need to have the basic knowledge about machine learning, right? So the best example is like we are like driving a manual transmission vehicle, and so we are going to train, like we are going to like have a bit practice on manual transmission vehicle and come to auto transmission vehicle, right? So that kind of a thing. The manual වාහනයක් drive කරලා auto වාහනයකට යනවා වගේ තමයි machine learning වලින් deep learning වලට යනවා කියන්නේ, right? දැන් මේ දවස්වල අපි මේ කරන applications deep learning neural networks Google Translate ගත්තා මම පෙන්නන්න ඉස්සරහට ඒ හැම application එකක්ම neural networks use කරලා තමයි කරන්නේ. ඒතකොට මේ අලුත් trend එක තමයි deep learning කියන්නේ. This deep learning concept is came in 2006, right? 2006. අලුත් දෙයක්, බොහොම අලුත් දෙයක් deep learning concept. But neural networks were there, I mean, from 1940s, 1960s, the idea was there. But the concept deep learning came into play in 2006. But machine learning, support tech machine, k-nearest neighbor algorithm, those are like coming from 50 years back, right? So machine learning is quite old and low-level algorithms, but high-level algorithms are in deep learning. So these are called neural networks, right? Okay. So I will explain the basics of machine learning, and today I'm going to go through a machine learning algorithm as well. Okay, quickly. So yes, we have a question. Currently, for like advanced applications, we are not going to use machine learning algorithms, right? Actually, we are not going to use machine learning for anything. I can't say like that, but for small applications, for simple applications, we may use machine learning algorithms. So you might have, what are these simple applications? මොනවද මේ simple applications කියලා ඔයාලට issue එකක් එන්නේ. අපි හිතමු මෙහෙම problem එකක්, okay, right? බොහොම සරල දෙයක්, okay, right? So you have like this, you have inputs like this: age, gender, cholesterol level, diabetes level, right? And smoking or not. ඔන්න වගේ factors ටික, right? Age, gender, blood glucose level, cholesterol level, and smoking or not. We have like 5 factors. using these 5 factors, we need the algorithm to predict whether this guy or this person is going to have a heart disease or not. Quite simple, right? I mean, what we have to take inputs like age, gender, smoking or not, blood glucose level, and what we say this blood glucose level and cholesterol level, and then there's algorithm which predicts whether whether this person is going to have a heart attack or heart disease or not. Quite simple problem. But if you take like translating Sinhala to English, right, or a self-driving car, so that's a quite, I mean, complicated related to the last example that I took, right? So if you have quite simple problem, right, you can use low level algorithm like machine learning algorithms, right? So you can use those algorithms for simple problems, quite simple, easily solved problems. But deep learning, since it's a high level version of machine learning and use neural networks, we can use neural networks for high level applications, complicated applications. I will show you some examples, then you will understand what I'm making, right? So nowadays, the trend, I mean, what we are using is neural network to solve our problems like that. And also like, okay, so let's say now we want to go from, right? Right, okay, so let's say now we want to go to Nugegoda from Maharagam, right? We want to go from Nugegoda to Maharagam. Maharagam is Nugegoda, right? So what we are going to do, like, we are going to like pick me or Uber. We are going to order a taxi, right? A tuk-tuk, let's say a three-wheeler, right? Okay. So you want to go to like from Maharagam to you want to go to Jaffna, right? So what you are going to do, you are going to uh, get a, I mean, three-wheeler. No, you can't, right? So then you may get like a SUV, right, or sedan or something like it's a car, right? A small car, let's say, right? So it's depend on the application. If your application නේද අපි මහරගින් නම් මෙහි යන්න එක ත්‍රිවිල් එකක යන්න පුළුවන් අපිට. හැබැයි අපි මහරගම ඉඳන් අපි හිතමු අපි යනවා කියලා යාපනයට. ඉතින් ඒ වගේ ටිකක් ලොකු ප්‍රොබ්ලම් එකක්. අන්න එතකොට අපි යූස් කරන්නේ අපි වාහනයක් ගන්නවා වෙලා, right? නේද? එහෙම කියලා අපි ත්‍රිවිල් එකේ යන්නේ නැහැ ඒක. අන්න ඒ වගේ තමයි machine learning use කරන්න පුළුවන් applications තියෙනවා. බොහොම simple applications we can use simple applications we can use machine learning. Deep learning is used for advanced, complicated, high-level applications, right? Okay. Now we will view some applications of real-world applications, some advanced applications of AI, right? And we try to understand how those things are working, right? Okay. Okay, so can you view my screen now? I mean, now my screen have like 4 sections. Yes, okay, right? So I'm going to now view some applications of artificial intelligence and mostly in deep learning, right? Can you hear the sound as well? Okay, great. So please come join me. One thing, good vibes only. I just cashed my check. I ain't paying rent. I just quit my job. Go to mall, get lost. Don't care who you are. Don't care where you from. We all got one thing in common. We just wanna have fun. Hey. Right, so can you uh, can you notice that we have like three cameras here, one here, one here, and one here, I think. Anyway, there is three, but I don't know whether this is the third camera, but you can notice that we have three cameras, right? Okay. Now the thing is, this is a practical application that we are going to discuss in like fifth or sixth week. We are going to do the same thing, and we are going to train a self-driving. We are going to train a neural network for self-driving car, right? So you may wonder whether we are going to do it for a real car. No, unfortunately, no. At the car, but what we are going to do the same thing, right? So to make the same thing, I'm going to do with you for a simulator. අපි දැන් ගේම් එකක් වගේ සිමියුලේටර් එකක් අරගෙන මෙන්න මේ self driving car එක implement කරනවා, right? So මම notice කරගන්න ගියේ මෙන්න මේ cameras තුනක් තියෙන එක අපි එදාට කතා කරනවා. අයි මේ cameras තුනකින් මේ signals ගන්න, images ගන්න කියලා, right? So මේ තියෙන Nvidia එකෙන් කරපු project එකක් 2016 හොඳට ගොඩක් සාර්ථක වුණ project එකක්, a successful project completed in 2016 by Nvidia, right? So you can see how it's driving. Right, so that's the application of convolutional type neural network, which we are going to discuss in most probably in the fourth week of the course, right? And this is again a self-driving car implemented by MIT University. So this is their project, and now they are not focusing on self-driving. Now it's already implemented, but now they are focusing on the driver activity recognition, right? See,
for a car is the MIT Human-Centered Autonomous Vehicle. But amongst our team, her name is Betty, as in Black Betty. Today, we'd like to demonstrate activity recognition. Two-stream neural network, optical flow, and RGB coming from the video of the driver's body. The output of the network is a prediction of the driver's activity, whether that's texting on the phone, drinking water, or playing guitar. All right, hey Betty, let's go for a drive.
Sure, Rex. With music?
Yes, play your theme song.
Would you like to play along?
Yes.
Ready?
Yes.
So can you see, like, it's now it's going to drive. I mean, it's going to drive itself, the car, but now it's going to recognize the driver activity here, right? See. Right, so this is again an application of convolutional neural network, right? So now see, now where the world is right now. දැන් බලන්න කොච්චර ලොකු applications තියනවද මේ neural networks, මේ deep learning මේ වගේ similar ඒවා තමයි අපි කතා කරන්නේ අපේ practicals වල. මේ වගේ දේවල් අපි implement කරනවා මම අර කියපු විදිහට, right? Okay, so the third one is object detection. You can see now. Right, let me movie segment here time apply kassin. Now you can see, right, I mean, it's going to detect almost all the object in a given frame, right? In a given frame, it's going to detect almost all the objects. Now this object detection is another another well-known field of convolutional neural networks, right? Object detection, and it's in a very advanced level now. I mean, object detection කියන ගොඩාක් advanced level එකක දැන් තියෙන්නේ. මොකද මේ neural networks වලට අපි වගේම objects අඳුර ගන්න පුළුවන්. අපි වගේම objects අඳුර ගන්න පුළුවන්. right? මට කියන්න දැන් අපි ඇත්තටම මේක experiments වලින් prove කරලා තියෙනවා. අපිට වඩා හොඳට neural networks වලට object අඳුර ගන්න පුළුවන් කියලා. Right? So it's proved that it has been proved that neural networks are better than humans when it comes to object detection, object recognition. Is it? එහෙමද? I can do experiment and show you the result now. මට දැන් උනත් experiment එකක් කියලා කරලා ඔයාලට පෙන්වන්න පුළුවන් මං කියන එක ඔයාලා අපිට වඩා හොඳට detect කරගන්න පුළුවන් කියලා. Right, so I'm not going to do it now, right? I will, when it comes to neural networks, I will show you that I can prove that the neural networks, the convolutional neural networks are performing well in object recognition than us, than humans, right? I will show you it in a coming week, right? Okay, so then this is a healthcare application where it's going to detect skin cancers, right? Skin cancers using neural networks, right? Using neural networks, right? So automobile, healthcare, right? Object detection. Again, this is another interesting thing.
Friends, what's going on? Rich on Tech here, and I've got to show you an app that is just super cool. You've probably heard about Google Translate. It's been around for a while, but it recently got a major upgrade, and now it's just pretty darn awesome. So what it does is it uses augmented reality to literally let you look through your phone at something that's in a different language and translate it instantly. It's kind of tough to explain, but let me just show you. So here's the app. I've got it running on this Samsung Galaxy Note 4, and there's some signs that are in Spanish. Okay, let's say I'm in a different country. All I have to do is aim my phone at that sign, and look at that. Immediately, you can see it change right on the screen from apague telefono mobile to turn off telephone mobile. Now, that's not perfect, but you get the gist of what they're trying to tell you. And the cool thing is, when you look at it on your phone screen, it's in the exact same font that it is on the paper there. So let's try another sign. It says Tienda Cerrada. And look at that. Oops. Store closed. And can you see both of those?
Right, so this is, I mean, this app is in your phone as well, right? So Google Translator, you can see it in the new latest update. You can see this, you can get this feature, right, where you can live translate something to another language. The thing is, now behind this, neural networks are working, right? So mainly the natural language translation, right? Natural language translation and machine translation. So machine translation is basically translating something from one language to another language. It's called machine translation, right? So this is the application of machine translation where we are going to talk it. We are going to discuss about it in under recurrent neural networks as well. අපි මේ වෙනත් recurrent neural networks වලද කතා කරනවා. මෙන්න මේ machine translation. So then chatbots, again application of recurrent neural networks and LSTMs. Natural language processing. This is called natural language processing application and recurrent neural networks. Right? Chatbots. Right? And this is what I was talking about. This music track is generated using artificial intelligence. No any real music or no any real instruments used, right? Purely using artificial intelligence, right? Can you see, right? So it's quite pleasant music track. And this is an application implemented by me, right, recently.
In this video, I'm going to discuss how kind of a face mask detector, and for this
using convolutional neural networks.
Use Python programming language together with K,
Right.
together with learning those kind of things.
So purely applications of convolutional neural networks and.
So before going into this video,
right.
if you are interested in learning.
Okay. So again, application of convolutional neural networks. Okay. Then this is another. Yes, Camilla, we are actually creating, chatbot. I'm trying to give it as an assignment or a practical session. So this one here, this is again another application developed by me recently. So you can see there's a website where we can upload the image, X-ray image, and it's going to predict whether this patient is having COVID-19 or COVID-19 positive or negative, right? So real application using again convolutional neural networks. And so see, now you can't see the neural network or you can't see the code. So we have integrated or we have deployed it to a web application, right? So this is not a rich web application with nice little colors, but you have the content, right? I mean, we can upload the image and the website says whether it's a positive or negative COVID-19, right, case. Now the thing is, here we have deployed a neural network behind a web application, right? So those things we are going to discuss in this class as well, in the last section of the class, right? So again, so this is actually an interesting video, right? Let's see.
The future of driving. Nothing to be afraid of. Because we're working on safer cars for a safer tomorrow. With large-scale data-driven development at the BMW Autonomous Driving Campus.
Right, so BMW, they are having their own driving campus, right? Autonomous driving campus. So that's where the world is right now. Okay, so one last video, right? So this is a quite interesting thing happened in 2016. This game is called AlphaGo, and the world champion, I think, 6-time consecutive world champion. මේකේ අවුරුදු 10ක් හරි එක දිගට world champion වුණ කොරියන් සවුත් කොරියන් ප්ලේයර්ව පරද්දනවා නියුරල් නෙට්වර්ක් එකකින්, right? අවුරුදු 6ක් world champion නියුරල් නෙට්වර්ක් එකකින් පරද්දනවා. මේකේ සම්පූර්ණ documentary film එකකුත් තියෙනවා බලන්න, right? So there is a documentary film as well, so you can later watch that.
Oldest continuously played board game. It is one of the simplest and also most abstract.
Beating a professional player at Go is a long-standing challenge of artificial intelligence.
Everything we've ever tried in AI just falls over when you try the game of Go.
The number of possible configurations of the board is more than the number of atoms in the universe.
AlphaGo found a way to learn how to play Go.
So far, AlphaGo has beaten every challenge we've given it, but we won't know its true strength until we play somebody who is at the top of the world, like Lisa Dong.
Like no other is about to get underway in South Korea.
They said all is to go what Roger Federer is to tennis.
Just the very thought of a machine playing a human is inherently intriguing.
The place is a madhouse.
Welcome to the DeepMind Challenge 4. It's watching. Can Lisa Dong find AlphaGo's weakness? Whoa. Is there in fact a weakness? The game kind of turned on its axis.
That is not a confident base.
very, very dangerous way. Hold the phone. Green has left the room. In the end, it isn't about pride. I hate kids something like wrong. Yeah, it's paying attention. It's got to be communicate. These ideas that are driving AlphaGo are going to drive our future. This is it, folks.
Right. බලන්න මේ movie එකම තියෙන සම්පූර්ණයෙන්, so that's a good example where the 6-time world champion was defeated by a neural network, right? So that's why I say they are performing well than us, right? But there's a small issue that now self-driving car is best for that neural network is best for self-driving. It cannot detect objects, or it cannot play this game, but we can drive, we can play games. අපිට හැමදේම කරන්න පුළුවන්. හැබැයි මේ application based neural networks තියෙන, right? So that advantage is there. Okay, so I can give hundred of examples today, right, about deep learning, neural networks, and those kind of examples, right? So every field we can have an application of neural networks, right? There might be applications of neural networks, and we can think, right? We can also, now this is another target of this course, another objective of this course, that I want to give you the knowledge where you can think of new applications, right? So you might think, okay, can we apply neural networks for this, right? Can we apply neural networks for this? Make it apply කරන්න පුළුවන්, make it apply කරන්න පුළුවන්. අන්න ඒ වගේ හිතන්න නැති applications වල neural network apply කරන්න පුළුවන්ද කියලා කරන්න knowledge එකක් මේ course එකේදී ඔයාලට ගන්න පුළුවන්, right? Okay, so I can give another reasons why you need to learn deep learning, machine learning, right? So we have a lot of job opportunities listed, right? ගොඩක් job opportunities තියෙනවා දැන්, AI engineers, right? Machine learning analysis, machine learning engineers, data scientists, AI engineers, so ගොඩක් job opportunities. We have job opportunities, and also the most important thing is now freelancing jobs are also there, right? So now few of my students are working on Fiverr and Upwork. They are getting good amount of jobs weekly, right? Related to deep learning and machine learning, right? For stock market, object detection, freelancing වලටත් දැන් graphic design, website design ගත්තොත් ඕන තරම් ඉන්න. හැබැයි neural network, deep learning, machine learning වලින් freelance කරන අය අඩුයි. ඉතින් කට්ටිය මගේ කලින් course වල students ලා දෙන්නෙක් මට කතා කරලා කිව්වා යාළුවට මේ වගේ ප්‍රශ්න ඇවිල්ලා තියෙනවා මේ මොකද කරන්න කියලා. මම ඇහුවාම ඒ කට්ටිය දැන් freelancing Fiverr එකේ සහ Upwork වල කරනවා කියලා කිව්වා. ඒ වගේ chances උත් ඕන තරම් තියෙනවා. ගොඩාක් industry වලට ගොඩාක් research. If you are like focusing on higher studies, right, a good field to do your research, and a good if you are like if you are, I mean, your career is related to computer science or IT or whatever the things, please focus on deep learning or machine learning, since in future, I mean, not the future I'm talking about, the future about like after 10 years, no, the soon future, like within this year, next year, like within like 5 years time, right, there will be a good demand. And now also we have the good demand, but the demand will be eventually, right, increased for this machine learning, deep learning, and these things. So it's best to focus your, I mean, you are from different backgrounds, you are from different jobs, or we are from different I mean, degree programs. It's fine. I mean, I'm asking you to focus. I'm asking you to narrow down your path to machine learning, deep learning, and this data science field, since then you might get lot of opportunities, right? So the best thing to have some open source projects. නේද? හොඳම දේ තමයි ඒක prove කරන්න සමහර open source projects, හොඳ open source projects ටිකක්. එහෙ නැත්නම් හොඳ projects ටිකක් ඔයා කරපු දේවල් ටිකක් තියාගන්න, right? So you can show. Now දැන් සමහර ඒවා දැකලා මම පොඩි applications ටිකක් පෙන්නන්නම්. Okay. මම පොඩි applications ටිකක් පෙන්නන්නම් ඔයාලට. මේ sorry මේ job opportunities ටිකක්. uh, uh, when we go, this is Google AI residency program and 18-month research training on Google. So you can apply to these things. Next intake will be soon, right? And right. So in these applications, you will find that they are requesting GitHub links, right? Make a right? Yes. Anyway, now they are looking for undergraduates with a bachelor's degree or master's or PhD, right? And they are saying that we highly encourage candidates from non-traditional backgrounds and experience from all over the world to apply this program, right? Right. මෙතන ගොඩක් දීලා නැහැ. හැබැයි මම මේක කියන්නම් mainly මේකේ like $6,500 per month salary එකක් හම්බ වෙනවා. 18 months 18 months internship program එකක්, right? මේකේ application එකේදී තියෙනවා එයාලා GitHub links ඉල්ලලා තියෙනවා. ඔයාගේ projects වල GitHub links දාන්න. දැන් මම කියන ලංකාවේ ගොඩක් මේක අඩුයි. In Sri Lanka it's not a trend that they are not asking for your project, I mean your coding skill, right? But in the world they are requesting for the coding skills, right? So I will show you another example. Right, so we have like this. I will show you mechanical machine learning. Anyway, that's not there now, right? So anyway, I want to show you that they are like looking for codes. සමහර තැන්වල codes ගොඩක් ඉල්ලනවා. Yes. Right. I'll show you those things later, but I have seen like in several job listings, they are requiring for GitHub links and your code skills, and they want to look for your like your coding skills, right? So those kind of chances are there. So it's better to narrow down your paths to deep learning, machine learning, right? So you are getting like you will benefited in soon future, right? Okay. Right. So now we start from here, right? AI, now we know what AI, the concept AI, then machine learning, now we are deep learning, right? So in this course, our focus will be on deep learning, right? So I will quickly go through that. We have several categories under deep learning, and I will explain these things in no time, right? So deep learning, mainly we can divide it into three main categories. And you can see this thing in the our course content as well. So we have mainly three types of categories: supervised deep learning, unsupervised deep learning, and reinforcement deep learning, right? So in the first first 6 weeks of the course, we will be focusing on supervised type deep learning, right? supervised type deep learning. Then eventually we are moving to the unsupervised and reinforcement deep learning, right? So supervised, unsupervised, and reinforcement, I will give you a quick example. What are the differences between these three categories? So supervised learning, it's like training, learn to swim with guidance of an instructor, right? So we are getting an instructor and we are trying to we are trying to learn swimming, right? We are trying to learn swimming uh, with the guidance of an instructor. So that's called the supervised type learning, right? Unsupervised type learning is simply like, okay, learn to swim by self-studying, right? That means we are not we don't have an instructor. That means no one to supervise us. But what we are going to do, by self-learn, that we are going to like learn swim by self-studying. We are going to do some self-study and swim, right? So that's what you call unsupervised, for example, right? So real world example. Then reinforcement learning is like the worst case, right? So what we are going to do, we are going to take you in the middle of the street and drop off you there. ගෙලිම මුහුද මැදට ගිහිල්ලා මුහුදට අතාරිනවා වගේ තමයි අපි කියන්නේ reinforcement learning. එතකොට ඒ වෙලාවේ යා real time, ඒ වෙලාවේ යා train වෙන්න ඕනේ, ඒ වෙලාවේ යා විදියක් හොයාගන්න ඕනේ බේරෙන්න, ඒ වෙලාවේ යා trial and error කරලා ඒ වෙලාවේ යා method එකක් හොයාගන්න ඕනේ swim කරන්න. අන්න ඒ වගේ දෙයක් තමයි reinforcement learning කියන්නේ. අපි බොහොම in detail මේවා ගැන කතා කරනවා. 7 වෙනි week එකේ unsupervised learning, 9 වෙනි week එකේ reinforcement learning අපි ගොඩක් හොඳට කතා කරනවා. හැබැයි අද ඉඳන් අපි focus කරන්නේ supervised learning ගැන. Supervised learning හොඳට අපි discuss කරලා, we are going to discuss supervised learning first and then cover everything, and eventually we will move on to unsupervised and reinforcement, right? So today onwards up to 6th week we are going to talk about supervised, but I'm not going to give you the introduction to unsupervised and reinforcement. I'm going to keep it as it is, since I don't want to like confuse you with this content, right? So what I'm do, let's take one, right? So we will finish supervised learning and then we will move on to the others, right? And මම supervised reinforcement learning ගැන කතා කරලා ගොඩක් මෙතන content එක වැඩි කරන්න යන්නේ නැහැ. මම supervised learning ගැන ඉස්සෙල්ලා කතා කරනවා. supervised learning කියන්නේ මොකක්ද කියලා. ඊට පස්සේ ඒකට අනුව ඒක ඉවර කරලා අපි unsupervised සහ reinforcement learning වලට යමු 6 වෙනි week එකෙන් පස්සේ, right? Okay. එහෙනම් so we are in deep learning and we are in supervised type deep learning from today onwards, right? Okay, so this is the supervised type model, right? So this is something that you have to keep in your mind, or you have to memorize, that the supervised type model, the supervised type learning model. So whenever we say supervised learning, you have to recall this thing, right? So I think you may have seen this earlier as well in our workshops and other times, right? But anyway, I will explain it from very basics. So we have algorithm. So this is called a neural network, since in deep learning algorithms are neural networks, right? Deep learning algorithms are neural networks, right? Okay. So what we are going to do first, we are going to train it for a specific application. Now what we are going to do, we are going to take an application, a problem, and we are going to train a neural network or an algorithm for that, right? So this is how we are going to do it using when we come to supervised learning. Supervised learning වලට ආවහම මෙහෙම තමයි මේ algorithms train කරන්නේ, right? So this is the supervised type learning model, as I mentioned earlier. So you have to keep this model in your mind. Okay, so this is a supervised type model like that. So now what I'm going to do, I'm going to take a problem application and I'm going to train a neural network to perform that application. So you can remember from the previous content that computer algorithms which can be trained for specific computer algorithms that can be trained for specific applications and use it for future predictions, right? So the deep learning is the same, but deep learning is a high level version, or it uses neural networks as the algorithms, right? Okay, coming back to this. Okay, so I have an algorithm and I'm going to train it to a specific task. That's what I'm going to do, right? Okay, so you have this algorithm. First I'm going to train it. When you are going to train it, you are going to find that we need two things, right? We need two things, features and labels, right? We need two things called features and labels, and we are going to train the algorithm using features and labels. The algorithm will be trained using features and labels. Then thereafter, so this is like the training part, right? This is the training part, right? So this is what we are going to do first, the training, right? So this is what we are going to do first. And we need two things, features and labels. So this is like training the neural network to perform a specific task, right? And this is the testing part, right? So this is like getting the future predictions. මෙතන තමයි අපි අර future predictions ගන්න කතාව කරන්නේ. Future predictions, right? Future predictions are getting using features, and we are going to get labels here, right? Labels you can see. The third one is getting the labels. So features and labels. අපිට දැන් මේ features and labels කියන එක ඉස්සලාම අඳුර ගන්න වෙනවා මේක තේරුම් ගන්න, right? So features and labels. So we will talk about these features and labels and try to move to the next section. So okay, anyway, now this is the supervised model. First you have to train it, then you can get future predictions, right? First you have to train it, then you can get future predictions. So this blue color box is the algorithm, and in order to train the neural network, you need two things called features and labels. So that's the most important thing that you have to remember. You need two things called features and labels in order to train a machine learning or deep learning algorithm, right? Okay, quickly. So this is example, right? So this is example. I'm going to get a simple problem, right? So this is not even, I mean, a real problem, but I'm going to assume, okay, so we have a problem. So I have a problem definition. I want to predict whether it's going to rain today or not. That's my problem. ඔන්න ඔක තමයි මගේ තියෙන ප්‍රශ්නේ. අද වහිනවද නැද්ද කියලා predict කරන්න ඕනේ. ඔන්න ඔක තමයි මගේ ප්‍රශ්නේ. මම මේකට supervised learning use කරනවා. ඇයි supervised learning use කරන්නේ? ඇයි අපිට use කරන්න බැයිද unsupervised reinforcement නැහැ. මම දැන් දන්නේ අපි දැන් කරන්නේ supervised algorithm, supervised learning තමයි අපි කතා කරන්නේ. ඒකින්ද අපි දැන් supervised learning වල විතරයි focus කරන්නේ. ඒකින්ද මෙතනට අපි supervised type learning algorithm එකක් use කරලා අද වහිනවද නැද්ද කියලා තමයි predict කරන්න යන්නේ. right? වහිනවද නැද්ද කියලා තමයි predict කරන්න යන්නේ. වහිනවද නැද්ද කියලා predict කරන්න යද්දී අපිට ඉස්සල්ලාම ඕනේ identify කරන්න දේවල් දෙකක්. මොනවද? Features සහ labels කියන දෙක අපි identify කරන්න. We need to identify features and labels before applying a problem or application into a neural network or any other algorithm. මොකක් හරි algorithm එකකට අපි deep learning apply කරන්න කලින් අපි බලන්න ඕනේ ඒ problem එකේ තියෙන features and labels අඳුර ගන්න. right? Features and labels අඳුර ගන්න අපි බලන්න ඕනේ. okay. So what are the features and labels? Right? Features and labels. So labels is quite straightforward. Identifying labels. Labels කියන එක අඳුර ගන්න ලේසි අපිට. දැන් මම මේ කතා කරන්නේ machine learning නැත්නම් deep learning algorithm එකකට algorithm එකක් අපි කොහොමද train කරන්න කියලා. train කරන්න මොනවද අපිට ඕනේ කියලා. right? So we need to know. You can remember the model. So in order to train it, we need features and labels. So we are trying to identify what are the features and labels here, right? Okay. Features. Before features, I will discuss about labels. Labels are the possible outcomes of the problem, right? Possible outcomes of the problem. So I'm going to predict whether it's going to rain today or not. අද වහිනවද නැද්ද නැත්නම් කවදා හරි දවසක වහිනවද නැද්ද කියලා තමයි මට අඳුර ගන්න ඕනේ. So in order to predict whether it's going to rain today or not, right? In order to predict whether it's going to rain today or not, yes, so in order to predict whether it's going to rain today or not, sorry, I'm going to identify features and labels. Okay, so labels are the possible outcomes of the problem. So what are the possible outcomes of this problem? මේ අපි ගන්න problem එකේ output එක මොනවද? What are the outcome? What is the outcome of this problem? Outcomes and what is the outcomes or outcomes of this problem? Right? මේ problem එකේ outcome එක විදිහට එන්න පුළුවන් මොනවද? Yes, exactly. Raining or not, right? Raining or not, right? So we have two classes. Those are called classes. We have two classes. Rain, no rain. Two possibilities, right? Right? Rain or no rain. වහිනවද නැද්ද? Labels දෙකයි. Right? එහෙනම් අපේ problem එකේ එන්න පුළුවන් possible solutions problems දෙකයි තියෙන්නේ. වහිනවද නැද්ද? Rain or no rain, right? Features කියන්නේ ඔන්න ඔය labels depend වෙන factors වලට. The critical attributes or the factors that the labels are dependent on. Labels are dependent on. Labels depend වෙන factors attributes වලට තමයි අපි කියන්නේ features. So can you give some examples quickly? Can you give some examples quickly? Yes. The critical factors or the attributes that the labels are dependent on. වහිනවද නැද්ද කියන එක depend වෙන factors මොනවද? So that's called the features of this problem. Quickly. Yes. We have answers. Yeah, we have. Yes, good. We have good answers. Yeah. Humidity, temperature and humidity. Yes, those things are there. Any other thing other than these two? Any other thing? So වහිනා නැද්ද කියලා දැන් අපි කොහොමද කියන්නේ අද පොඩ්ඩක් එළියට ගිහිල්ලා බලලා වහිනා. Yes, wind speed. Right? The wind speed, let's say wind speed. Other than that? Cloudy, yes. Cloud in the sense we can take it like now somehow we have to convert this into numbers, right? So we have to deal with numbers. So cloudy, how can we convert it to numbers, right? Like we can say the atmospheric pressure, exactly, we can get that. The cloudy, how we can convert it to a number? We can get the light intensity, right? Yes, cloud density, the light intensity, right? The light intensity, right? Or the, yes, history statics, we can exactly get those things, right? So we have like several factors that we can get, or the features we can get, right? So those are the features and labels. Now this is the most important point, right? Identifying the labels and the features. So if we can like define features and labels, then it's quite easy for us to like do whatever the necessary things, the remaining necessary things, right? Okay, so features and labels, I'm going to like do what? The second point. So first we identify the features and labels, then I'm going to find or create a data set, right? So this data set should be collected, right? So I mean this data set should be a real data set. That means this data in this data set should be real and accurate. That means this should be past data. මේවා ඇත්ත data වෙන්න ඕනේ. කලින් දවස් කියන්නේ කලින් මාසවල හරි කලින් අවුරුද්දේ හරි දවස්වල data වෙන්න ඕනේ මේක. අපි කියමු මේ තියෙන day 1, right? Like this. Day 1 කියන්නේ නේද? Day 1, day 2. දැන් මේ day 1 කියලා කියන්නේ කවද්ද? 2010 පළවෙනි මාසේ 4. එහෙම එකක් වෙන්න පුළුවන්, right? I don't know. But it should be a real date. It should be a real data entry, right? It should be real. That's the most important thing, right? So that's how we are going to create. And these 6 entities are not going to do this for us, right? So we need like thousands, or we need like millions sometimes, right? අර මම පෙන්වන්නේ self-driving car එකක්, right? That self-driving car is trained using 7.7 million images at the initial stage. 7.7 million images. 7.7 million images, right? So the maker but this, I mean, we need, sometimes we may need like data in thousands, right? 10,000, sometimes 100,000, sometimes millions, depend on the applications. We need bulk data, right? So that's something that you have to keep in your mind, right? So then what we are going to do, we are going to train the algorithm, right? Features, right? So we are going to take these things and apply here, and we are going to take these things and apply here. So the features and labels, we are going to train it. The algorithm will be trained using features and labels, right? So that's how we are going to train. Now we can like think it like features and labels. Also, I will give you a indication that we can think them as X and Y as well, right? X and Y. But here we have like X in the sense we have like, right? We have X1 and X2, right? That means temperature X1, sorry, humidity X2, right? Then what we are going to do, we are going to train the algorithm, train the machine learning algorithm, right? So you can see the annotations, right? I mean, whatever the things I'm drawing. Okay, right? Right, so yeah, so that's it, right? And we are going to train it, right? So we can think of like features X1 and X2 label as Y, right? So we can think of it as X and Y, right? Right? So the machine learning algorithm will be trained, right? So this machine learning algorithm will be trained using features and labels, right? So what is this training is like, right? මොකද්ද මේ training කියලා වෙන්නේ, right? So can you remember that the first word that we spoke, right? Or that we pronounce, I mean, yeah, we spoke, let's say, the first word, most probably amma, තාත්තා, right? So amma hari තාත්තා hari කියලා අපි කිව්වා කියලා හිතමු, right? අපි කොහොමද ඔක train උනේ? So අපි කොහොමද ඒ අම්මා තාත්තා කියලා කියවම මේ පොඩි නිකන් real world example එකක් වාර කියන්නේ, right? So do you believe that that's like months or years of training? ඔයාලට තේරෙනවද ඒක අවුරුද්දක නැත්නම් අවුරුදු දෙක තුනක training, අවුරුදු මාස ගානක නැත්නම් අවුරුද්දක training එකක් අම්මා the first word that you do, like I'm saying that you took like 1 year or few months training to say your first word. Say your for your first word you take like 1 month or 1 year or several months training. Why? Huh? So what's going to happen? Your mom comes, right? And she's like okay, saying, so she's pointed at her and say, okay, I'm amma mama amma mata amma kiyanne, I'm mother, right? mama mata amma mama amma mata amma kiyanne, right? ඔය වගේ ඔයාට ඇහෙනවා ඇති මොකද වෙන්නේ. So you are going to see the figure of your mom, right? The figure of your mom, and also you are going to heard the term mom, amma. ඒ වෙලාවෙම කනට ඇහෙනවා අම්මා කියලා. අම්මගේ රූපේ දකිනවා, අම්මා කියන එක කනට ඇහෙනවා. The figure and the word amma, right? Amma, right? So it's going to like continue for like several months or several years sometimes, right? ඉතින් මොකද එකම දකිනවා ඔය අම්මා, right? මේකත් මූණක් දකිනවා කනටත් ඇහෙනවා, right? So what will happen? You are undergoing a training unintentionally, right? So then what will happen? There's a testing as well, right? So then අම්මා ඇවිල්ලා මොකද කියන්නේ? මම කවුද කියලා අහනවා. එතකොට ඔයා ඉබේම මොකද කියන්නේ සමහර වෙලාවට? මොකුත් කියන්නේ නැත්තම් වගේ ට්‍රේනින් එක මදි තාම. ආයේ මම අම්මා කියන්න මට අම්මා කියන්න right ආයෙ ට්‍රේනින් එක වෙනවා ඒ ට්‍රේනින් එකදී ඔයා පාස් නම් මොකද කියන්නේ මම කවුද කියලා අහපුවාම ඔයා දකින්න අර මට පොයින්ට් කරන්නේ අම්මට පොයින්ට් කරන්නේ අම්මට පොයින්ට් කරද්දී අම්මා කියලා කියනවා right so this is like the human learning process අපි ඉගෙන ගන්නවා වගේම තමයි අපි ගොඩක් දේවල් ඉගෙන ගත්තෙත් ඔය වගේ supervised learning වලින්ම තමයි මම ඔයාලට example පෙන්නන්නම් අපි සමහර තැන්වල supervised learning කරලා තියෙනවා සමහර තැන්වල unsupervised learning කරලා තියෙනවා සමහර තැන්වල reinforcement learning අපි use කරනවා right so මේක හරිම interesting මොකද දන්නවද මේක මේ artificial intelligence කියන්නේ ඇත්තටම real intelligence human intelligence වලට ගොඩක් ළඟයි right අපි බලමු ඉස්සරහට so anyway දැන් machine learning algorithm එක මොකද කරන්නේ machine learning algorithm එකත් එහෙම තමයි දැන් අර වෙලාවේ අම්මගේ figure එක තමයි feature එක උනේ label එක උනේ අම්මා කියන වචනේ right සමහරට තාත්තත් වෙනවා තාත්තයි figure එක තාත්තා කියන වචනේ මේ වගේ ගොඩක් features and labels තියෙන්න පුළුවන් right okay so anyway then yeah so here also we have some features and labels then මේ වෙලාවේ feature temperature humidity label එක වෙන්නේ 0 1 right so here temperature and humidity the label will be rain or no rain right so what we are going to do yes what happened the system read different data from what we have given while implementing yes the thing is now it will be approximation right so that means like okay 28 80 31 50 33 right so sometimes when we are going to get predictions there might be a data point which the algorithm had never seen algorithm එක කවදාවත් දැකලා නැති temperature එක humidity combination එකක් එන්න පුළුවන්. එතකොට කොහොමද prediction එක දෙන්නේ? හොඳ ප්‍රශ්නයක්. එතකොට approximation එකක් අතර මෙතන එන්නේ බොහොම ලස්සන දෙයක් මම පෙන්නන්නම් approximation එකක් වෙන්නේ. ඒ කියන්නේ දැන් self driving car එකක් කියලා සමහර self driving car එකක් අපි කොළඹ train කරලා අපිට වෙන කියන්නේ එක town එක train කරලා වෙන පාරක යවන්න පුළුවන්. ඒක ප්‍රශ්නයක් නෑ. තේරෙනවද? එහෙම නැත්නම් දැන් අර object face mask detection එක කියනවා. ඒක face mask කියවම ලෝකේ ඉන්න හැම මිනිස්සෙක්ගේම face mask face එක detect කරගන්න පුළුවන්. right COVID-19 detection කියලා හැම ඕන x-ray එකකින් detect කරගන්න පුළුවන්. සමහර තැන්වලදී වැරදිනවා but ගොඩක් වෙලාවට accurate. මම මේක කතා කරන්නම් ඉස්සරහට. right yeah sorry about GIF yeah okay sorry I didn't notice that's a private one okay yes so the problem is what happened the system read different data from what we have given while implement this system in real world right so the problem is okay now we are going to give a data set like this right we are going to give a data set like this so we are going to train it using this data set right so the question is what will happen in the prediction the future predictions if there is a unseen data in the sense okay so there is a temperature and humidity combination that the algorithm had never seen right algorithm had never seen so in that case what will happen right not I mean don't worry about that since in machine learning or deep learning we are going to do some approximation right so no matter whether the data is unseen it's going to give a prediction sometimes it will be the correct prediction sometimes it might not be the correct prediction right the issue is somehow now practically let's say okay we have a face detection face detection algorithm so we are going to train it using let's say faces in America but it's going to work for China it's going to not sure about China but it's going to work for like Sri Lanka India African countries European countries right so let's take a self-driving car the self-driving car might be trained in another country but it will perform in another country right? So that's going to happen. Since in machine learning or deep learning, mainly we are going to do approximations, right? Approximations. I will explain these things, right? Okay. So we are going to train it using features and labels, as I mentioned, right? Features and labels, as I mentioned. And yes, so yeah, so yes, right? So then the algorithm is going to learn, right? So when you are training, the algorithm is going to learn features and labels x, y, x, y. For this feature, this is the label. This feature, this is the label. This feature, this is the label, right? Understood. Now it's like, let's say the best example that I can give. So we are preparing for an exam, let's say. We are preparing for an exam, right? So exam is coming on like 1 year time, let's say, or 3 months time, let's say. So what we are going to do, okay, we are going to take a past paper. අපි past paper එකක් ගන්නවා. The past paper, now we are going to get a question, right? We are going to get a first question. And we know we are going to write the answer, right? And also we are going to get the answer and see the real answer in the marking scheme, right? In the result on the in the marking scheme on the or the answer at the end of the book, at the end of the past paper, right? So question and answers. So it's like features and labels, questions, answers, questions, answers, questions, answers. So we are going to train, our brain is going to be trained with questions, corresponding answers, questions, answers, features, labels, x, y, x, y, likewise, right? Then our brain, let's say we are going to consider our brain as the algorithm. So we are going to like train on those x and y, right? Then what I mean, how the training is happening, like it's going to take like, okay, it's going to identify the connection or the relationship between features and labels, right? It's going to identify the connection or the relationship between features and labels, right? For this feature, this label, this feature, this label, this feature, this label. So I can say it like what? This algorithm is, this is not, I mean, don't think it's like y equal m. Anyway, I will first write it. Y equal f x. So the algorithm is trying to develop a function y equal fx. That means it's going to find the relationship between y and x. Y as a function of x. Y as a function of x. Right? Now don't think that this function is like something like this, right? Right? Not like this. Not exactly like this. I will explain these things in coming weeks as well. Not exactly like this, but a function y equal fx. Y as a function of x. That means now if we know if like with simple mathematics, what we can say, if we know y as a function of x, when x is given, what will happen? We can find y. That's what you know. That's what you say, that you know a function, right? That means if you know y equal fx, a function, let's say we know that a function called y equal fx. So what will happen when x is given, we can find y. That means what? When features are given, we can find the label, right? So machine learning algorithm is going to do that. Machine learning algorithm is going to find the relationship between y and x. That means machine learning algorithm is going to identify the relationship between x and y, features and labels. So then what will happen? It's like an approximation. It's going to approximate y as a function of x, right? I will explain how this is going to happen later, but this is what happens, right? Then what will happen after the training? What we can do? We can give x1 bar, x2 bar. bar is for like training test data, let's say. So I'm going to like today temperature and today's humidity. I'm going to give today's temperature and today's humidity. So the machine learning algorithm, the deep learning algorithm that we trained, right? The deep learning algorithm that we trained is going to give us the label. That means y. Understood, right? So this is what supervised machine learning is about, right? So we are going to identify features and labels, right? And using features and labels, we are going to find a data set. And the data set, using the features and labels, we are going to train it, right? And the machine learning algorithm is trying to identify, I mean, training in the sense, machine learning algorithm is trying to build up a relationship between features and labels like y equal fx, approximated function. Then what will happen? Whenever the feature in the testing, when the features are given, the machine learning algorithm is going to predict a label, right? So that's what's going to happen. Simply that's what's happening in supervised type learning. Understood, right? So any issues regarding this? Anyway, actually the thing is now I will basically discuss these things in detail, right? But this is the overall idea, right? Okay. Right? Okay, right? So we will move, right? So we have mainly, so that's how it's worked, right? So keep that idea in mind. We have mainly two types of problems when we are going to apply it to a machine learning algorithm, right? Or deep learning algorithm. When you are going to apply a deep learning or machine learning algorithm into a problem, when we are going to apply a problem into deep learning or machine learning algorithm, we have to identify the problem type. We have two main problem types in machine learning and deep learning. Those are called classification problems and regression problems, right? So mainly classification is when the label. So now we are going to categorize the problem as classification or regression based on the label, right? We are going to, based on the label, we are going to classify it as classification or regression, right? Okay. So classification is basically dealing with discrete labels in the sense categories, right? So let's say rain today or not, rain, no rain. That means two classes. Then we are going to predict, let's say, whether a patient is going to, when an X-ray image is given, we are going to predict COVID-19 positive or COVID-19 negative, right? As COVID-19 negative or COVID-19 positive, right? Two labels, right? Or when the image is given, we are going to predict it as like cat, dog, or rabbit. We are going to give an image and there is a machine deep learning algorithm and it's going to predict whether this is a cat, dog, or rabbit, right? Or else we are going to give, let's say, age, gender, and let's say the blood glucose level and the cholesterol level and smoking or not. So it's going to give us like whether this patient is going to have a heart attack or not, right? Likewise, if we have a categorical label, right? That means a label, if a label is a category, if the labels are categorical labels, label like a category එකක් නම් අපි කියනවා classification problem එකක්. So then we call it like a classification problem, right? So second type is regression type problems. So regression type problems are the problems where the label is a continuous number. That means like this, okay. We are going to predict the rainfall in millimeters, not whether it's going to rain today or not, but we are going to predict the rainfall today in millimeters, right? In the self-driving car, we are going to predict the steering angle. So steering angle is like from positive range to negative range, right? The angle. And also we are going to predict the stock price of a particular stock tomorrow, right? හෙට මොකක් හරි ස්ටොක් එකක ප්‍රයිස් එක අපි predict කරනවා. So that's a continue number එකක්, right? So we are going to predict like risk of having a heart disease. So that can be vary from 0 to 100, right? So it's like when we are going to deal with the problem where it has a label in a finite range from a positive or a negative number within a range. If we have the label within a range, then we can say that's a regression type problem, right? So classification is when we have categories, right? Like whether the stock is going to up or remain in the same level or going down. So three possibilities. So that's three categories. It's a classification problem. But if you are going to like predict the stock price, right? So that can be like in a range. So that's called a regression problem. So before creating the data set, before doing anything, before deciding the machine learning or the deep learning algorithm that we are going to use for this case, what we have to do, we have to identify whether this problem is a regression problem or a classification problem, since the analysis that we are going to do, the neural network types that we are going to use, the functions that we are going to do, the pre-processing techniques that we are going to use, right? Those are dependent on the problem type. I mean, we are going to follow different steps for regression problems. We are going to follow different problems or classification problems. So when you have a problem, first we need to identify whether this is a classification or a regression type problem. That is something that we need to do, and it's quite easy understanding whether the problem is a classification type or a regression type problem. We have some examples. Okay. Application, self-driving car. Features, right? So what are the features? Self-driving car, in the self-driving car. So I will explain it now. In a self-driving car, the features will be an image captured from the camera, right? Image captured from the camera attached in the front, right? An image. So features, I mean, okay, features are image. So how many features are there in the image? Okay, now I told that, okay, in a self-driving car, the features will be the image given, right? So the image. So how many features are there? Or what are the things that we are going to take as features in the image? No. Objects, no. Any other? I mean, the image features කියලා කියන්නේ මොනවද ඇත්තටම? Yes, exactly. Pixels, right? So the pixels of this image will be taken as the features. Okay, so if we have like 50 by 50 image, height 50, width 50, so we have like 25,000 features, 2,500 features, sorry, right? So then the label will be the steering angle, right? Label will be the steering angle. Okay, so you can see now the problem type, right? So this is a regression type problem. Now I know that you have a problem. Okay, self-driving cars, we are going to get the image and the label will be the steering angle, right? So what about the accelerating? I mean, what about the throttle? What about the brakes, right? What about the brake, and what about the acceleration? Yeah, the speed. And what about the other objects in the road? How we are going to control them? How we are going to control them? In the self-driving car, we have mainly like several controlling mechanisms. One is this, right? Taking the image and predicting the steering angle. That is something, I mean, that's one thing. We have like other control mechanisms for speed, I mean, the accelerating, the throttle, and to like to stop at the color lights, right? Stop when there is pedestrians, and stop when there is like other vehicles, right? So we have different, I mean, we have another, we have several other controlling mechanisms, but the mainly the steering angle will be controlled by taking an image, right? So stock market, right? So this everything will be done in our course, so you will then get better understanding about these things. So stock market values, usually we are going to, like, in a time period, we are going to take the stock price, like let's say last 50 days, from today onwards, last 50 days. So we are going to, like, take this kind of a pattern, the stock value of a specific company, right? Specific shares, right? And then the features will be last 50 days stock price, and the label will be tomorrow's stock price, that we are going to predict the tomorrow's stock price, right? So don't worry, we are going to, like, do the stock market value prediction in this course as well, most probably in the 6th week under recurrent neural networks. So then we will do this kind of application. I'm just giving you the overview to make you familiarize with these concepts. And yeah, COVID-19 prediction using X-ray images, right? So the X-ray image will be the feature, the image will be the input, and pixels will be the features, right? Pixels will be the features, right? And the label will be COVID-19 negative or COVID-19 positive, right? So you can see directly, right? So steering angle from minus values to positive, I don't know, let's say minus 180 to plus 180 angle, right? So it's a regression problem. This is again what? A regression problem, right? So this is a classification problem, since we have two labels, COVID-19 positive or COVID-19 negative. And chatbots, usually what we are doing, we are training, we are getting features like dialogue, right? Questions and answers, right? A question dialogue and the answer dialogue. So feature will be question dialogue, and the target label will be the answer dialogue, likewise, right? And object detection APIs. So we are going to discuss about object detection API. So you can remember that the object detection, that film segment, we detected the object. So that's using object detection API. So we are discussing about object detection APIs as well in the 5th week. So in object detection APIs, the features will be the image again, and we are going to predict a class, whether cat, dog, apple, toothbrush, bicycle, vehicle, right? Sorry, car, truck. Likewise, we are going to predict a category. So then it will be a category classification problem. And risk of having a heart disease, age, gender, total cholesterol level, HDL, high density lipid something, and smoking or not. Then the label will be the risk of having a heart disease, 0 to 100. So can you answer, like, the 6th application, is it a classification problem or a regression problem? Yeah, it's a regression, right? So this is a number between 0 and 100. Yes, it's a regression. Good. Okay, so now what I'm going to do, I will quickly go through a machine learning algorithm, right? Not deep learning. I told you that we are going to start the neural networks deep learning part next week, but I will go through a machine learning algorithm and explain you how machine learning algorithm can be applied for a supervised type problem, right? Machine learning supervised type problem එකකට machine learning algorithm එකක් කොහොමද apply කරන්න යන්නේ කියලා අපි කතා කරන්න යන්නේ, right? Okay. Right? So we have several machine learning algorithms, right? Linear regression, support vector machine, right? Decision tree classifier, right? Logistic regression. Those kind of machine learning algorithms are there available, but I'm not going to go through all of those things, right? but I will show you. So don't get confused. These are machine learning algorithms, not deep learning algorithms. We are going to discuss about deep learning algorithms separately from from next week onwards. But I want to get you familiarize these terms. That's all, right? So we have classification type supervised learning algorithms in machine learning called support vector machine, nearest neighbor, decision tree, Gaussian naive Bayes, right? And we have classification type unsupervised learning algorithms called k-means clustering. So these are the algorithms that I was discussing when I'm giving when I was giving the introduction about machine learning, the trainable algorithms I say, right? So these are the trainable algorithm types that are available in machine learning. I'm not going to focus on these things. These are not in our syllabus, right? So we are not going to discuss about these things, but our focus will be on deep neural networks, the deep learning algorithms. But I will quickly go through these things, right? So regression type algorithms, we have linear regression, support vector machine, right? Dimensional regression algorithms, right? Those kind of algorithms are there, right? Okay. Right. So now what I'm going to do, I'm going to use the k nearest neighbor algorithm. So this k nearest neighbor algorithm is a supervised type machine learning algorithm, a classification type supervised learning machine learning algorithm, right? Supervised machine learning algorithm, a classification type algorithm, right? Okay. So this is used in like several applications, right? Like political science, handwritten image detection, image recognition, those kind of things. But nowadays we are not going to use them in our applications, since we have like advanced algorithms like deep learning, and neural networks are performing well than these things. But these were there before neural network come into play, right? Before deep learning concept come into play, these machine learning algorithms were there, right? They were there and they were used for applications. But nowadays it's hardly used, since the deep learning or neural networks, deep learning and neural network algorithms are giving good performances than these things, right? Okay. So I'm talking about k nearest neighbor algorithm, and let's see how it's going to, first let's see how it's going to be trained when the features and labels are given, and let's see how to get a future prediction using k nearest neighbor algorithm, right? Then you will understand how these machine learning algorithms are working, right? Okay. Right. So you can remember the last example that we took, right? The last example in the sense that we created a data set, humidity, humidity and temperature, and we predicted that, we want to predict that whether it's going to rain today or not, right? So what we are going to do, first we know that we are going to do the training part, right? So this is how it's going to be trained. Right? So we are going to apply features and labels, right? So features will be, the humidity and temperature, and the label will be 0 or 1, right? So in the training, actually nothing happens in k nearest neighbor algorithm. Nothing happens in k nearest neighbor algorithm. It's like we are going to plot it in this kind of a graph. Let's say it's like just loading this data, right? So then I'm going to this is an illustration, not a real data set, right? Just an illustration. So I'm going to take feature 1 into x axis and feature 2 into the y-axis, right? Feature 1 into the x-axis and feature 2 into the y-axis. Then I'm going to place, the data set, right? So day 1, let's say this is day 1. Day 1 temperature and day 1 humidity, right? This is day 2, let's say. This is day 2 temperature and this is day 2 humidity. Understood, right? So likewise, I'm going to place it in this kind of a graph, right? Day by day, I'm going to get day by day, and temperature and humidity, I'm going to place these points, right? So this is, let's say, day 3, temperature is this kind, right? Humidity is, right? Likewise, I'm going to place it, and this is not accurate these are not real data. That's what I'm telling, right? Okay. So then, let's say we have like 100 days. I'm going to plot it in this kind of a graph, right? I'm going to plot it in this kind of a graph. Then what we are going to do, I'm going to like show it the rain class and no rain class using 2 colors. Let's say the red color is for no rain and green color is for rain, right? So 2 colors are there, no rain and rain, right? So this is what happening in training. Nothing actually happened. It's like it's placing it in this kind of a graph, right? Okay. So now the training is done. Nothing happens. This is only what happens, right? Then what we are going to do, we are going to get a prediction, right? Okay. So what we are going to do, we have a day. Today, let's say, today temperature is 31 and humidity is, let's say, 55. Right. In the training part, can there be duplicate feature with different label values? In the training part, can there be duplicate feature with different label values? Yes, it can be. Right? It can be. Yes, it can be. There can be. Yeah, good question. Right now, let's see what we can do with that kind of issues, right? So you will see what to do with that kind of issue. So you will understand how we are going to like play with those kind of situations, right? Okay. Now we are in the training part, right? So the testing part. We are going to get a prediction. So the second part we are in now, right? And what we are going to do, we are going to get day to be detected today, let's say, right? Then I'm going to like place it in the same graph, right? So let's say temperature is 31 and the humidity is 55, right? Okay. So this yellow color point is to be predicted. That means whether it's going to rain today or not, we have to predict it, right? We have to predict it, right? So we have the temperature and the humidity today, right? Today data we have temperature and humidity. So we want to predict whether it's going to rain today or not, right? Whether it's going to rain today or not. So what we are going to do, right? What we are going to do, k nearest neighbor, k nearest neighbor. Let's keep k part. We will discuss about k later. Nearest neighbor, nearest neighbor. ළඟම ඉන්න එක්කෙනා අපි බලනවා ළඟම ඉන්නේ කවුද කියලා, right? ළඟම ඉන්න එක්කෙනා. So we have to get the nearest data point, right? So what we are going to do, we can now we can say we can see that the nearest one, right? So we can see the nearest one, right? So what's the nearest one? This one, right? This one is the nearest one, as we can see, right? But the computer can't see, like it's not going to actually, it's not going to plot this kind of a thing, right? මේවායක් ඇත්තටම අඳින්නේ නැහැ. මම මේවාට පෙන්වන්නයි මෙහෙම එකක් ඇඳලා පෙන්නන්න. නැත්තම් මෙහෙම මෙහෙම ඇඳලා එයා බලන්නේ නැහැ. අපිට වගේ ඇස් නැහැ නේ graph එකක් ඇඳලා බලන්න. So what will happen actually, it's going to measure all the distances to all the points in the data set, right? So let's say in the training data set we had like 100 days, right? දවස් 100ක් තිබ්බ කියලා හිතන්න 100 days. So what we have to do, all of the 100 days we have like measure the distance to the points, right? That means we have like 100 days, that means we have 100 data points. So when there is a day to be predicted, that means we are going to get a prediction. When we are going to get a prediction like 3155, so we want to whether it's 1 or 0, that means rain or not. We have to measure the distances to the all the points in the training data set, right? So what we are going to do, what the k-nearest neighbor algorithm is going to do, it's going to measure all the distances to all the points and select the data point with the minimum distance, right? It's going to measure the distances, right, from the testing data points, I mean the yellow color point, to the all the data points in the training data, right? And out of them it's going to select the data point with the minimum distance, right? So as you can see here, this color, the pink color point is the minimum distance. So what it's going to do, then it's going to get like, okay, my nearest neighbor is no rain class, in no rain category, right? So what's going to do, it's going to predict this point as no rain. Since the nearest neighbor is a no rain one. ළඟම කෙනා වහින්න නැති දවසක්. ඉතින් මෙයාත් කියනවා අදත් වහින්නේ නැහැ කියලා. Right? Understood. See, so this is the, I mean, any issues, right? So this is the simplest machine, though this is a machine learning, this is not deep learning, right? So deep learning algorithms are like, we are going to spend one day to understand a deep learning, I mean the feed forward neural networks. We are going to like take one day to understand feed forward, but this is a simple algorithm, right? So you can see, quite simple. So it's going to find the nearest one. So then unknown data point is there, unknown data point is there, the day to be predicted, this yellow color thing. So it's going to do what? Measure the distances to all the training data points and select the data point, the nearest data point, that data point with the minimum distance to the testing data, and predict the what? It's going to predict that point as the nearest points label. ළඟම ලේබල් එක වැස්සේ නැති ලේබල් එකක් නම් මෙයා කියනවා මේකත් වහින්නේ නැහැ කියලා. මේ දවසත් වහින්නේ නැහැ කියලා. කහ පාට දවසත් වහින්නේ නැහැ කියලා. Understood, right? So that's how machine learning, k-nearest neighbor algorithm works, right? Okay, now how it's going to measure this distance? Huh? How it's going to measure this distance? D is equals to what? D is equals to what? Huh? Don't give me the equation, like let's say what's the like theorem we are going to use to find this distance? Quickly. Yes. Yes, Pythagoras, right? So what? Right. So likewise, we are going to measure all the distance and select the minimum distance, and the data point, the label of that the data point with the minimum distance will be the predicted thing, right? So that's how the machine learning algorithms are working. So this is one of the machine learning algorithms called k nearest neighbor. We have a lot of other algorithms like support vector machine, logistic regression, decision tree classifiers. We have a lot, but this is how the k nearest neighbor algorithm works, right? Okay. Okay, right. Okay, now I'm going to assume some there's another issue with this as well. Okay. Now, let's assume that I'm going to make this point a green color one. Okay, right? Assume that this is a green color one, right? Now what will happen? Yes, yes. Okay. Yeah, now we have a question. Okay, what will happen, right? What happens if the rain and no rain points are same distance from the day to be predicted point, right? Right? Okay, I'm going to do something like this. Let's say, okay, right? So let's say I will answer that question later, but let me do this. Okay. So let's say this is the day to be predicted. I will answer your question later, but I first I will highlight this point. Okay, so this is the day to be predicted, right? This is the day to be predicted, and assume that this is a green color point. Okay, now tell me, according to the k nearest neighbor algorithm, what will be the prediction for the yellow color one or the orange color one? What's the prediction? Is it a no rain or rain day? Rain day, right? But is it fair to predict it as a rainy day? Is it fair to predict it as a rainy day? No. What's the reason? What is the reason? What's the reason? Yeah, it's called an outlier. Exactly, that's the word, outlier. Now we have the, I mean, this is due to like, it's an outlier, right? Yeah, it's an outlier. That means the most of the points are red, but there is an outlier. දැන් අහම්බෙන් වැටුණ එකක් මෙතනට මොකක් හරි හේතුවක් හින්දා මොකක් හරි නේද බෙන්ගාල බුක්කේ අවපාතයක් වගේ මොකක් හරි කේසයක් හින්දා හරි මොකක් හරි හින්දා මෙතනට අහම්බෙන් වැටුණ එකක් outlier. We call it like an outlier. So the nearest neighbor will be outlier, but it's going to predict it as, so it's not fair. It's not fair, right? It's not fair to predict it like that, right? So what will happen, right? The k, now this is where the k comes, k nearest neighbor, right? We can define the k value like k equal, usually we are using odd number, k equal 3, k equal 5, k equal 7, likewise. But by default, k will be 1. K will be 1, right? Default k will be 1, right? But we can define k. Now, what will happen when k equal 1? It's not going to take the nearest neighbor, but it's going to take 3 nearest neighbors. Three nearest neighbors. 3 nearest neighbors. 1, 2, and 3. Right? Then what's going to do? Then it's going to take the majority. මෙතන ඉන්න වැඩියෙන් ඉන්නේ කවුද කියලා බලනවා. කොළ එක්කෙනයි රතු දෙන්නයි. එහෙනම් ළඟම හිටපු එක්කෙනා, right? It's not going to be a matter. The nearest one is a green one, but it's not going to be a matter since we have the majority of red. 2 reds are there. Nearest neighbor is this. So in this case, it's going to predict it as a no rain. Right? So in like this, we can overcome that outlier issue, right? So in this case, what will happen if, like, now your question, right? So what if there are 2 data points in different classes in the same distance? Not going to be a matter, right? So we can select k equal 3 and the issue will be solved, right? But these kind of things are very rare, right? It's not going to happen all of the times, right? These are like very rare. So we can select a value for k, like k equal 3, 5, 7. Now you may have a question how to select the k value. It's up to you. You can change those values and see the performance, and you can decide the k value, right? Okay, so this is simply how a machine learning algorithm, to be exact, the k nearest neighbor algorithm works, right? Now you can understand how features and label the y equal fx, right? The features and how to get the relationship between features and labels, right? But the thing is, this is the method of k nearest neighbor. This is how k nearest neighbor works. But the decision tree algorithm works some other method, and logistic regression method works with some other method, right? And neural network follows very different method, right? So we have several methods, but this is one example of a machine learning algorithm. So keep that in mind. This is one algorithm I discussed about. The suppose vector machine works in a different method, right? So this is how k nearest neighbors works, right? Okay, so quickly, so this is when we have like 2 features, so you can get the Pythagoras distance. But if the dimensions are more than 2, that means features are more than 2, like we have temperature, humidity, but temperature, humidity, wind speed, light intensity, we have some other features as well. So in that case, what we can do, we can use the Euclidean distance. What do you mean by Euclidean distance, right? We are going to take now, this is the temperature difference, this is the humidity difference, right? Right? Temperature, humidity difference, and wind speed difference. Likewise, we can add more features for the k nearest neighbor, right? Right? Okay. Okay. So now, what will happen? So we have some examples here. So if you are like dealing with the image, the features will be the pixels, as I mentioned. If you are dealing with the stock market value, these last 50 days or last 100 days stock values will be the features, right? And if you take like speech recognition, this kind of a voice signal will be the feature. Or if you take a self-driving car, again the image will be the features, right? So now in these examples that I'm showing you here, the features are like complicated and high level features, we can say. They are like not like temperature and humidity. නේද? temperature humidity වගේ නේ මෙතන කීයක් තියනවද? image එක pixel එක image එක pixel 2500ක් තියෙන්න පුළුවන්. Right? Understood? Features එකක් දෙකක් නෙමෙයි. Now here in this case there might be features like 50 features for 50 days. Right? 50 features for 50 days. So if you are like taking 10 seconds of a voice signal, then we have like several amplitudes, right? So if you take an image of, as I mentioned earlier, 100 by 100 or 50 by 50, we have like 25,000 pixels, right? So when like features are getting complicated and features are getting high level, we can't use the traditional machine learning algorithms, right? Now you can see how this is going to solve this kind of a simple, right? Quite simple. But here two features, right? We have only two features here. But we are not going to use k nearest neighbor like for self-driving car. We can't use that, right? Since we have like a lot of features here, we can't use that. Understood? So when problem is getting complicated, and when problem is getting high level, I mean, when its problem is getting advanced, we can't use traditional machine learning algorithms, right? We can't use traditional machine learning algorithms. That's where neural networks comes into play, right? So traditional machine learning algorithms can be used for the problem that I explained, right? But when it's getting complicated, if the problem is getting complicated, we can't use machine learning algorithms for that, right? Understood? Right? So in that case, for deal with advanced applications, high level applications, we are using deep learning, right? Deep learning and neural networks coming into play, right? That's where neural networks coming into play. So deep learning, I will explain these things next week, right? But I will quickly go through. Deep learning is like advanced and it's performing well than machine learning algorithms. And I want to highlight this point. We have several neural network architectures. Under supervised type deep learning, we have feed-forward neural networks, convolutional neural networks, recurrent neural networks. These are the three main types of neural networks. And under unsupervised learning, we have two main types of neural networks, autoencoders and generative adversarial networks. And under reinforcement learning, we have deep QNets, right? The feed-forward neural networks, convolutional neural networks, and recurrent neural networks, these are supervised, as I mentioned. And feed-forward neural networks are used for simple applications like similar applications that we can solve with machine learning, right? For similar applications that we can solve using machine learning, we are going to use feed-forward neural networks. And like simple applications, like we are going to take age, gender, blood glucose level, and other stuffs and predict the risk of having heart disease. Likewise, convolutional neural networks are used for image-based applications, right? All the image-based applications are like we are going to use convolutional neural networks for image-based applications, object detection, video recognition, those kind of. Convolutional neural networks are actually good for pattern recognition. And recurrent neural networks, we are mainly going to use recurrent neural networks for time series data analysis, time series data, stock market values, speech recognition, natural language processing, those kind of applications. And this encoder decoder architecture is not a main type. These are the three main types. But what we can do, we can mix these models. I mean, we can mix convolutional and recurrent. We can create hybrid models. Like using convolution and recurrent, we can use like RCNs, RCLs, recurrent convolutional neural networks. That means this encoder decoder architecture is basically representing like the mixed models or hybrid models combining these three. මේ තුන එකතු කරලා හදනවා තමයි encoder decoder architecture කියලා කියන්නේ. ඒ mainly supervised learning වල තියෙන්නේ මේ ටික. බොහොම simple problem වලට features අඩු problems අපි use කරන feed forward neural networks. ඊළඟට convolutional neural networks අපි use කරන image based application වලට. recurrent neural networks අපි use කරන්නේ time series data analysis වලට. unsupervised learning, noise removal, data extraction වගේ වැඩවලට අපි auto encoders use කරනවා. ඊට පස්සේ fake data generation, අර මම music generation පෙන්වන්නේ අන්න වගේ music generation අලුත් data generate කරන්න, fake data generate කරන්න තමයි අපි generative adversarial networks use කරන්නේ. auto encoders මම කිව්වා noise removal task වලට ගොඩක් auto encoders use කරනවා. ඊට පස්සේ reinforcement learning ගොඩක් use කරනවා trading bots ලා හදන්න. ඔය stock market වල trade කරන bots ලා හදන්න. ඊට පස්සේ games වලට reinforcement learning use කරනවා. ඒ වගේ ගොඩක් applications තියෙනවා. games and right trading bots, right? Those kind of applications are reinforcement learning applications. So this is what actually we are going to start from next week, right? Okay. So we will cover these things on next week, neural network architectures and feed forward neural networks, and we will go through these things and learn how neural networks are working, right, on next week. Okay. So now what you have to do, on Tuesday we will, as I mentioned, Tuesday we are going to conduct our first practical session. So in order to implement that, you need to download the Anaconda Navigator individual edition. You can download it from here, and no matter whether you are using what OS, you can download the 64 graphical install and use it in your computer. That's fine, right? And right, so another thing that there is my YouTube channel, the Perceptron. You can search the YouTube channel. So there are a lot of tutorials and lot of examples that I have uploaded here. So you can go through these things and get an understanding about these things. And most importantly, this is where you can get the introduction to machine learning, right? This is where you can get a good introduction to machine learning, and everything that we discussed under machine learning is here. So please go through this video as well, and some other videos are there, so you can view it. And I will post the WhatsApp group, right, the link to the WhatsApp group quickly in the chat. Right, so I'm going to send the link from the chat, right? Sorry, I have to send it to everyone, right? So you can use this link. So please copy this link if you have not joined the WhatsApp group. So it's a good place where we can discuss everything, and I will post you everything there, right? So this video links and other stuffs will be posted there. And also now I will upload this video tonight to this online lecture here, right? So you can later view it. And also this slideshow, I will upload it here as well. So you can download it here from this point, this online lecture, and do the things, right? Okay, now in each day we have like a 1 hour session after the lecture, now starting from now, right? So where you can ask any questions if you have, you can clarify anything. After the lecture we have 1 hour where we can discuss everything. So if you have any question, you can ask them now. And also please join to the WhatsApp group if you have not, and we will follow the plan as we discussed now, right? So before going on to that, right, now I want to like get to know you, right? So what we can do, please one by one, right? So let's take 5 minutes and shall we introduce ourselves? So I have already done that. So one by one, please let get us to know. So then everyone knows how who are in this group, and like so we can get to know each other. So please mention your name and what you are currently doing and what's your interest on deep learning and those kind of things, right? Okay, so please one by one.
Hello,
Hello. Yeah.
I'm Lakmal. I am working as a tech lead at commercial bank,
Okay.
and so I did my MSc in computer science, University of Colombo.
Yes.
So my research also based on the MFIC mood prediction actually. So I'm trying to move from this normal software engineering field to this machine learning things.
Okay.
So that is why I select this course, because I have done a lot of other training materials with the LinkedIn and Coursera and Udemy also.
Yeah.
So, but I see big difference with those courses and the one you conducted. So I think I can get more out of you other than the other courses.
Yeah.
And
Yes, Harinder.
okay.
Yeah, thank you very much, Harinder. Yeah. Yes, so others, please. So we are getting late to the dinner. Yes.
Hi, actually, I'm Kushan here.
Hi, Kushan. Yes.
Yeah, I'm also attached to Commercial Bank as a senior software engineer, and currently I'm into software. So I'm also much interested about this machine learning, and my path will also be into this in future. So uh, hope to learn this pretty well.
Yeah, Kushan. Thank you very much. So this is Kushan.
Okay,
Okay.
thanks.
Yes. Others? Okay, so we have Gaurishwaran. Yeah, NDIT student and graduate student of Columbia University. Yes, okay. So you are interested in your MSc research? Yes, okay. Yes, so others, please quickly. So I mean, better to know each other, right? So yes, quickly. Yes, others, quickly. Then we can wind up the session. Yeah, so we have a finally undergraduate, Asiri. Yeah, okay. Others? Just turn on your mic, will you? Okay, right. So anyway, right. So we will get to know each other on next week, right? So I think, okay, we have another one. Yes, Lakshan. Yeah, biotechnical graduate, looking forward to masters. Okay, okay, great. Right, okay. So it's getting late. So okay, Suteshan. Okay. Yeah, we have Dasun here, second year electronic graduate. Yeah, okay. So interest on neural network. Yes, so what I see is we have like professionals, undergraduates. Yes, good, right? So that's what I actually wanted, right? So we can then discuss about these things. Now I'm asking about these things, so then I can then adapt myself to I know what are the materials, so what I need to explain more, right? So then I know everyone, each other very well, so we can have a better understanding. Okay, so anyway, so we will get to know each others as well, probably on next week, let's say, right? Okay, so thank you very much, and if you have any other questions other than this, please ask. Otherwise, I will wind up the session for now. Please join to the WhatsApp group and mention if you have any issues there, and try to be interactive in the group, right? Okay, so anything to be clarified or anything to be discussed before winding up the session? Okay, so thank you very much, and good night, everyone. So next week we will meet on this Tuesday at 6 to 8. We will familiarize with Python programming, and we will create our background and the fundamentals and the foundation for throughout our course, since we are using Python in our course throughout the course. So it's a most important point where you are going to get the coding skills and the skill that you need to complete the whole course, right? So hope to see you all there. And if you have any issues, as I mentioned, regarding the payments, please feel free to contact me. Just drop me a message, right? So I will then make necessary arrangements, right? Okay, so thank you very much, and meet you on Tuesday, right? Okay, so good night, and yeah, good night.